All right, here we go. We are working on section P.4. All right, first period. What's up? We'll talk about that in a minute. First period, I went a lot more in depth than I needed to, so this video will be helpful for them. But guys, we're talking today about radicals and rational exponents. Rational exponent just means a fraction. If I looked here and I was asked to simplify, this is asking for the cube root of 27, that little number in front. God bless you, it's called the index. That tells you you're looking for a number multiplied by itself that many times. So what number times itself 3 times gives me 27? 3. Good. What number times itself 4 times gives me 256? Take a guess. 4. What number times itself 4 times do you think gives me 625? 5, okay? We're not going to get much bigger than that because you guys don't have a calculator. But we are going to see things written with rational exponents. Rational exponent means a fraction. So rational exponent means fraction, okay? So pay attention to that. What this is saying, 64 to the 1/2 power. That's not saying 64 divided by 2. Whenever you have an exponent that is a fraction, the little number, the denominator, becomes what's called the index. That's the little number in front of the root sign. So what this is really saying is the square root of 64. What is the square root of 64? 8. Okay, so it's important for you guys to understand. If I just have this, what is the little number in front that we just assume is there? Read that to me. What does that say? Square root of 81. So square root, it's a 2, yeah. If it was a 3, it'd be the cube root. If it was a 4, it'd be the 4th root, something like that. So when you have a fraction, the denominator becomes that little number, the index in front. Okay, math talk. If n is any positive integer, then the principal nth root of a is defined as follows. That's just what I said. That means nothing to you, I know that. Here's some root rules, just like we had rules for our exponents. All right? Exponents and roots are just inverses of each other. So what this is saying right here, this is asking you for the cube root of -8 times 27. You could multiply -8 times 27 and then figure out what number times itself 3 times gives you that. Or you can separate it. Do you see how, since this was written under the same, we'll call it house, you separated it into these two things. It's much easier to do because the cube root of -8 is -2. What number times itself 3 times gives you -8? Then the cube root of 27 is 3. What number times itself 3 times gives you 27? Then you can just multiply them together. Same thing if you have a fraction underneath a radical. This is saying the 4th root of 16 divided by 81. Well, you can separate it so you don't have to do the 16 divided by 81, what times itself. Just separate it, and then you can simplify. How do you think they went here to here?
Because 2.
Right? There's a little imaginary 2 here. So what did they do with the 2 and the 3? Multiplied it. Just like if I had 3 to the 2nd power times to the 4th power, what would you do with these two? You'd multiply them. Same thing. What happens when you have a square root squared, or a cube root cubed, or 4th root to the 4th? They cancel out. Okay? So now we're going to simplify. Simplifying expressions involving nth roots. Okay, we're going to talk about different ways to write this. We're going to talk about simplifying. Simplifying means make smaller. Sometimes you're going to see simplify the expression. Sometimes you're going to see write the expression with rational roots. What this is saying is, what is the cube root of x to the 4th? A lot of times when you guys see letters, you don't like it. When you have roots and stuff like this, letters are more fun. It's better. I don't want to say more fun, but better. So cute. Okay, so let's rewrite this. The cube root of how many x's are underneath the radical? 4, okay? The index, that little number in front, tells you how many you have to have in a group in order to pull it out. So how many x's do I have to have in order to pull out a common factor? I have to have 3 of them. So I can pull out one group, x, and I'm left with what? 1 underneath. That's how you simplify that. You don't really have to do much thinking there. The little number tells you how many are in a group. If I have this, I'm going to just break this up into a bunch of different problems. I have the fourth root of 81 times the fourth root of x to the 8th times the fourth root of y to the 4th. So let's think about it. The fourth root of 81, what number times itself 4 times do you think will give you 81?
3.
It is 3. Now I have the fourth root of x to the 8th. You can do this. You can write out 8 x's. And now how many need to be in a group in order for me to be able to pull it out? 4. So here's a group of 4. And here's a group of 4. How many groups am I going to pull out?
2.
So it's x squared. And then what about y? 1 group. Yep. Now another way you can look at that, guys. What did I tell you? If I had x to the 8th to the 4th root. If it was written as a fraction, the index becomes the what? Where does it move to? The denominator, right? So if I had this 8 to the x over 4, could you simplify 8 divided by 4? And get what?
2.
Which is what we got, right? All you're doing is just dividing. But if you don't see that, it's not a big deal. Just go ahead and write them all out and then circle. It's easier that way, then do that. Okay, combining radicals. This is a very simple concept. You guys already know how to do this. You just may not remember seeing it. But if I had 3x plus 2y, and I said, okay, combine those two. Can I?
No.
Why not?
They're different variables.
Different variables. Same exact thing goes for roots. If I had 2 root 5 plus 3 root 2, I cannot combine those because they're different last names, we'll say, different roots. So the first thing you do when you see something like this and they say to combine, try and break it down. That's not as broken down as it can be. What can I break 32 down into? 8 and 4, I agree. What else? 2 and 16. So if I break this down into 16 times 2, perfect square and a non-perfect square, plus what can I break 200 into? What's a perfect square and a non-perfect square in 200? 100 times what? 2. Okay. Good. So if I simplify, what is the square root of 16?
4.
So this becomes 4 root 2 plus what? What's the square root of 100? So this becomes 10 root 2. What do you now notice about the quote-unquote last names? They're the same. So if I have 4 root 2's and then I have 10 root 2's, how many total root 2's do I have? 14 root 2. Make sense? Okay. Now somebody asked first period, what happens if I break it down and I get 4 root 2 plus 3 root 3? And it says to combine. Can you go any further?
No.
So that would be it. You would just leave it just like that. If their radical is not the same, you treat it just like you would if it was a variable. If that was 4x plus 3y, you could not. But on the one in red, if it was 4x plus 10x, you would tell me it was 14x. Make sense? Alrighty. Okay, we already talked about this a little bit. But what this is saying is, do you see how this little n, the denominator becomes the index and vice versa. So that's what we're going to do. If you look at these next examples, it says, use the definition of rational exponents. You're going to simplify. You want to make this smaller. You want to get the answer. So let's look and see how we can do this. What's another way I could write 4 to the 1/2?
4.5.
Good thinking, but where does that little 2 go? Becomes the index, right? So this is really the square root of 4, which is what? 2. Look at this one. First of all, what's the first thing that jumps into your head? There's a negative what? But where is it? Where is that negative? It's in the exponent. How do we make exponents become positive? Put it in the denominator. So I'm going to rewrite this as 1 over 125 to the 1/3 power. I can simplify that. I know what the answer to this is. What does that little 3 become? The index. So this is really, what do we hear? Cube root of 125. Well, what number times itself 3 times gives me 125? There you go. Good. Okay, 8 to the 2/3. How can I rewrite that? Okay, cube root of 8 squared. Watch, guys, there's 2 ways you can do this. Either way will work. Depending on the size of the number is how you'll want to do something. You can square 8, which is what? And then take the cube root. What number times itself 3 times gives you 64? 4. Okay, you can do it that way. Or you could do it the other way. You can cube root first. What's the cube root of 8?
2.
So I have 2 squared, right? Because I still have the squared. What's 2 squared? 4. Sometimes it's easier to do the root first if the number is big and then square it than going vice versa. Like if you had 100, you'd want to do the root first and then square or cube or whatever, rather than getting a huge number underneath the radical and trying to figure that out in your head. Make sense? Okay. Oh, we'll come back to that. Now, use the law of exponents with rational exponents. All right? You're going to keep your answer in a rational exponent. Means what is going to be in the exponent? A fraction. When I see rational, so think about this, guys. This is a to something times a to something. When you have the same base, what do you do to the exponents? Same exact process as before. I have a to the, what's 1/3 plus 7/3? A to the 8/3. Now, right now, I'm not asking you to simplify this anymore. But if I did, that little 3 becomes the what? The index. So this would really be saying the cube root of a to the what? 8th. And if I was going to simplify that more, I'd write out my 8 a's. 1, 2, 3, 4. And how many need to be in a group for me to pull it out?
3.
So I can take out 2 groups, right? And that's what I'm left over with. You guys don't have to do that. I'm just showing you to go further. That's how you would do it. Look at this one. This one looks gross, but it's really not. Simplify the numerator first. I have the same base, and I'm doing what? I'm adding. Well, I'm multiplying, so what am I going to do to the exponents? I'm going to add. What's 2 plus 7? So I have a to the 9/5 divided by a to the 3/5. Well, now I have the same base, and I'm doing what? I'm dividing, so what do I do to the exponents? Subtract. So I had a to the what? 6/5. You're just going from one thing to another. Sure. If I were to go further to simplify, that 5 would become the what? The index. So it would be the 5th root of a to the 6th. You would take out 1a, that sort of thing. But you don't have to do that right now. This is all I need for the first one, for right now. You don't have to worry about the further simplification. We're going to do that later. Okay, same thing. Using our law of exponents with rational. Guys, how do we have a power outside. So what does that mean I have to do with that power on the outside? Distribute it to everything. Good. So here, here, and here. So you can rewrite it as 2 to the 3 halves times a. What's 3 over? It's a whole number. So it's 3 over 1 times 3 over 2, right? And then I have b, 4 over 1 times 3 over 2. Well, we know how to multiply fractions. That's no big deal. What would my a simplify to? A to the what?
6 over 2.
Multiply.
9 over 2.
Yep, 9 over 2. What would my b simplify to?
12 over 2.
Which is? Yep.
6.
Cross cancel here. 6. Whoops, sorry. This becomes a 2, and then 2 times 3 is 6. Now, that number, 2 to the 3 halves, what does the 2 become?
The power.
The index, right? So it's the square root of 2 cubed. What is 2 cubed?
8.
8. So square root of 8. Can I break that down? 4 and 2?
Yeah.
So this becomes 2 root 2. And again, the more we do this, the easier it'll get, I promise.
Wait, how come you got the 4?
What's the square root of 4?
2.
But if it tells you to use rational exponents, then just keep your exponents as fractions. You just got to pay attention to what the directions say. Is that it on that slide? Okay. Okay. Use law of exponents with rational. Keep it as rational. Guys, this is a big problem, but you know how to do everything. You can start attacking this however you would like. What I'm going to do is I'm going to look at the first parenthesis and then the second one, independent of each other. And then we'll talk about combining and all that. But I have a 3 as an exponent. I have a parenthesis raised to a power. So what does that mean I have to do with this power of 3? Distribute it to what? Everything. So I have 2 to the 3rd power, x to the 3 over 4 times what? 3 over 1. And then on the bottom, I have y to the 1/3 time to the what? 3 over 1. Anybody have any questions? All right, now we have this first parenthesis. Now let's look at the second one. How can I rewrite the second parenthesis? Do I do anything with the y?
No.
No, just leave it. Y to the 4th. What else?
Bring the x up.
Good. Bring the x up. Why?
Because
This
it's
is
negative.
negative.
Because it's negative. Good. So there's a 1 on the bottom. All the rules that we've talked about. All the rules that we talked about. We're just going to go through and simplify. So in the first parenthesis, what's 2 to the 3rd power?
8.
So I have 8. Good. And then I have x to the what?
9 over 4.
9 over 4. Do you guys see that?
Yeah.
Anybody have questions? Whoops, I forgot to put my x. X to the 9 over 4. And then what's in the denominator?
3 over 3. Oh, 1.
Good. I'm glad you said that. You talked yourself through. That was good. So then I have in the other numerator, y to the 4th, x to the 1/2. Agreed? Okay, so we can still simplify a little more. Can't do anything with the 8. Just rewrite the 8. What do you notice about the y's? Do I have the same base and I'm dividing them?
Yes.
Yes, so if I have the same base and I'm dividing, what do I do to exponents?
Subtract.
Subtract. So this becomes 3. So I have y to the 3rd. And then look, I have x to the 9/4 times x to the 1/2. Well, it's the same base. So what am I doing to the exponents? I'm going to add them. Do they have the same denominator?
No.
No. Is that a problem?
Yes.
Yes. What is the common denominator between 4 and 2? 4. So this would really become to the 2/4. Agreed? So when I add, I have x to the what? 11 over 4. Nothing at all that we're doing here is new, except for the fractions. But we've already done fractions in the first section. We added and subtracted them. We multiplied and divided. So all we're doing now is applying all of the rules that we've talked about the first 2 weeks of school. So far, so good? Okay. Let's scoot a little bit more. What's the little number in front of the first radical? What's the index, that little number on the front?
2.
It's a 2, right? We assume it's a 2 if we don't see one. So all we're doing, guys, is we're multiplying, correct? Right? So multiply the numbers. What's 2 times 3? 6. And then what did that sheet tell me to do if I was multiplying a root to a root? If I was if I had a power raised to a power, what would I do to the exponents? If I had x squared to the 4th, what would I do with these two numbers? Multiply them. So if I have a root to a root, what do? Multiply. So this becomes that. What about here? What's the little number that I don't see? 2. So this is really what? 4th root of x. Good. Let's go back up here. I can simplify this a little more. How can I write that with a rational exponent?
X to the 145.
Good. On the bottom it would be x to the 1/4. Good. And then what is this one? 6. What?
1/6.
X to the 1/6. Where do we get the 1 from? Why'd you say 1?
Because it's a root.
Yeah. It's the exponent here. If you don't see 1, what do you assume it is? 1. Good. Very good. I know it's a lot at one time. One more thing I'm going to look at, and then I'm going to let you guys go. We'll talk about a little more rationalization later, but let's just look at this one. If you had me for Algebra 2, or pre-calculus, or for both, you should know the answer to this. What is wrong, Josh, Valerie, and Alexis? What is wrong with this problem that we're looking at? Vincente, Joshua. Why did I even ask you? Thank you. There's a square root on the bottom. Can you have a square root on the bottom of a fraction? No, you're going to get thrown into math jail.
You put the one on the bottom on top.
You do. You rationalize. You're going to multiply the top and bottom by the radical, and I'll show you why in a second. But, guys, if I say 2 times root 3, all you do is stick them together. Like if I had 2 times x, you would just say 2x. Same thing. I would rewrite this as 2 root 3. And then if I take the square root of 3 and times it by the square root of 3. Well, what's the square root of 3 times the square root of 3? Square root of 9. What is the square root of 9? 3. So when you multiply two radicals together that are the same root, all you're doing is just canceling out. So this becomes 2 root 3 over 3. And we'll talk about that a little more. Tomorrow we're going to get into a little more rationalizing. But I know I threw a lot at you guys today. It's good for you. Okay.